All right, so now we are doing 6.4, where we are going to explore the topic of radians and arc length. We are not going to cover angular speed, but it's something that's pretty interesting. So if you are a physics type person, it might be something interesting to read up on, but I don't have to teach it, so in the interest of time, we are not. So the first thing we're going to cover is radians. So radians is a unit of measure for angles. Okay, so we have up until now been using this 360 degree circle, right? We've said all the way around is 360 degrees. But this 360 degrees is a bit arbitrary. It came from the era of, everything being 60 seconds in a minute, 60 seconds or 60 minutes in an hour. And it kind of came, I want to say Greek or Babylonian. It's like one of those times where they just decided that around a circle would be 360 degrees. And I'm sure they had a reason for it, but I don't know what it is. But mathematicians went, hey, wait a minute, let's stop being so arbitrary. Let's just stop saying, hey, 360 degrees is a circle. Let's root our measures of angles in math. So what they did is they said, hey, we know that the circumference of a circle is equal to 2 pi r. So how they discovered that is that they measured the circumferences of a whole bunch of circles, and they said, hey, how does circumference compare with diameter, or radius, 2 times the radius? And they said that, oh, hey, wait a minute, we always come up with this number pi. So what they decided was that we should measure angles in a circle in terms of pi as well. So what happened is they said, well, 360 degrees is the whole way around a circle, just like the circumference is the whole way around a circle. And so instead of measuring it in degrees, we say, hey, it's going to be 2 pi radians. So that's where radian measure came from. 2 pi's is the number of times that a radius will go around a circle. So now what we have to do is become familiar or comfortable with all of our, degree measures that we've started to work on in radians. So what we're going to do is we're going to first explore something that I should have made another one of these for, but it's okay. We're going to explore our, what were they called? Quadrantal angles. So we're going to start with 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And we're going to look at it in terms of circle geometry, what would they be in radians? So 0 degrees would be 0 radians. Okay, we know that all the way around is 2 pi radians. So now we want to figure out the 3 other quadrantal angles in terms of this. Well, there's a couple ways of doing it. So if you think of it as this is breaking it up into 4, right? This is a quarter of the way around. So it's a quarter of 2 pi. So we could say that 90 degrees is equal to pi by 2. Then we could say that to go here, this is sorry, this is half of the way around. And so I would say 2 pi by 2, or just pi. Then if I wanted to go around here, okay, this would be 3/4 of the way to pi. Now 3/4 times 2 pi is going to leave us with 3 pi by 2. So you can think of going around a circle in quarters, right? A quarter of 2 pi, half of 2 pi, 3/4 of 2 pi, and then all the way to 2 pi. Or some people get good at this. They're like, okay, well, this is 0. Half of the way around is pi, cool. And then they go half again. So half of the way to pi is pi by 2. And then you'd have to be like, okay, well, I'm 1.5 times past pi to get 3 pi by 2 here. So however that makes sense to you. But we now know our quadrantal angles. 0 degrees is 0 radians. 90 degrees is pi by 2. 180 degrees is pi. 270 degrees is 3 pi by 2. And 360 degrees is 2 pi. Now, one thing that was asked in class today is how come I keep saying it's pi by 2? I think it's because it comes from pi divided by 2, and they just take out the word divided because it's always read pi by 2, 3 pi by 2, and that's just how radian measure is talked about, and I hadn't really thought of that before. Okay, the next one I want to work on is cutting these quadrantal angles up in halves again. So I'm going to talk about my pi by 4s. In other words, I'm going to talk about my quarters. So if you look at this triangle, this angle here is halfway between 0 and pi by 2. So halfway between 0 and pi by 2 would be pi by 4. In fact, if I start talking about it like this, I could say that this is 1 pi by 4. I could say that pi by 2 is 2 pi by 4. Then I would say that this middle angle here is going to be 3 pi by 4. And then I would say that pi is 4 pi by 4. Right? So 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4. Now we're getting greater than pi. So now we go into this guy here and we'd say that it's 5 pi by 4. And then we go down here and we'd say it's 6 pi by 4, which is still 3 pi by 2. Then we'd say that this is 7 pi by 4. And then this guy would be 8 pi by 4. So if we break our quadrantal angles up into half, we get our what angles, right? Half of 90 is 45. So what we just found is that 45 degrees is pi by 4. Halfway to pi by 2, or halfway to 90, is pi by 4. And then we could keep going. So 135 degrees is a reference angle of 45 degrees in the second quadrant, right? And so we would say that that's our 3 pi by 4. And then we've got our pi. And then we're going to move to 225 as our 5 pi by 4. And then we'd move to 315 is our 7 pi by 4. And then lastly 8 pi by 4. I didn't talk about 6 pi by 4 is this guy, and then 8 pi by 4. So now we've looked at breaking our circle up into quarters instead of halves. Now what we're going to move on to is breaking it up into sixths, I think. I was trying to decide after class, like, which should I start with? I'm going to go to the sixths. So what is a sixth of the way to pi? Well, if pi is 180 degrees, a sixth of the way to pi would be 30 degrees. So 30 degrees is pi by 6. Okay, now let's go around the circle like that. So this is 1 pi by 6. Where would 2 pi by 6s be? Well, let's break it up into another sixth. So this is 2 pi by 6, which simplifies to pi by 3, which we'll talk about in a sec. And then up here we'd get 3 pi by 6, which simplifies to pi by 2. Okay, and then we go to this one here, and we'd say that this one is 4 pi by 6, which simplifies to 2 pi by 3. We go to here, and we'd have 5 pi by 6, and then we'd get 6 pi by 6. Okay, I want you to pause the video and I want you to try to fill out the other side of this circle. So keep going in 6. So we had 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6. What would come next? So hopefully you paused the video and you found that this is 7 pi by 6. This division here would give you 8 pi by 6. Now 8 pi by 6 can simplify to 4 pi by 3. 4 pi by 3. And then we'd have 9 pi by 6, which simplifies to 3 pi by 2. And then we'd go to this angle here, would be our 10 pi by 6. And then we'd have this angle here, which simplifies to 5 pi by 3. And then we'd have 11 pi by 6. And then you'd have 12 pi by 6. Whew, so that covered a lot. So when we think about 30 degrees, so we're thinking about things making a reference angle of 30 degrees with the x-axis, we've got pi by 6 in here. And then we have the 5 pi by 6 in here. So when you go 30 degrees less than 180, in other words 150 degrees, is 5 pi by 6. When you go 30 degrees more than pi, or 180 degrees, right? Then it's going to be your 7 pi by 6. So that's 210 is going to be 7 pi by 6. And then same thing here, if we're talking about 30 degrees, right? Then it's going to be 11 pi by 6. 11 pi by 6. So just to recap, what we're doing here is we are looking at all of our special angles in every single quadrant. So the first thing we started was our quadrantal angles. We had these in halves: 0, pi by 2, pi, 3 pi by 2, and 2 pi. Then we went into 45 degrees and we're like, okay, well those are halfway betweens. So we had pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Then we went into our 30 degrees, and those are all going to be in terms of pi by 6. So 30 degrees is a sixth of the way to 180. So you'd have pi by 6, 5 pi by 6, 7 pi by 6, 11 pi by 6. And then the last angles we want to fill in are the ones that are equivalent to 60. So things that have a reference angle of 60 degrees with the x-axis. So 60 degrees is a third of the way to 180, so it's pi by 3. So the pi by 3 ones are these ones. These are the angles here that make a reference angle of 60 degrees with the x-axis, which we're not going to really talk about, like the reference angle idea, until chapter 7, but I just want to introduce it to you now. But we get here, we get that 1 pi by 3. Here we'd get that 2 pi by 3. And then this one would be 3 pi by 3. And then down here is your 4 pi by 3. And then here would be your 5 pi by 3. And then here would be your 6 pi by 3. Okay, so in other words, 60 degrees is pi by 3, 120 is 2 pi by 3, 240, which is 60 degrees past 180, is your 4 pi by 3, and then 300 degrees is your 5 pi by 3. And we could have got all those angles in terms of 30, right? Because it goes 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. But I can't help myself just reminding you that these are going to link to reference angles. We aren't going to do it in this chapter, but it's going to come up in chapter 7. And I feel like if we have this here as a reference, maybe it'll help us in chapter 7. But the key thing that you're supposed to get in this is just starting to think about radian measure. Okay, radian measure being that it takes 2 pi's to go all the way around a circle. So what are some of the common things that we're going to break this up into? Well, we're going to break it up into 45s, pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. We're going to break these up into 30 degrees, pi by 6, 2 pi by 6, which is pi by 3, right? 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6, and so on. And just recognizing that in 30 degrees, we can also see our 60 degrees as well. Okay, so hopefully you feel kind of okay with that, because now the questions in the textbook will look like this. Sketch a unit circle, which I've done for you, and mark the points determined by the given real numbers. So for this first one, they want you to break your unit circle up into fourths. So we're going to look at, the quarters, right? This is 1 pi by 4. This is, I guess you got to go here too. I'm going to put them all in. I'm going to draw and then talk. Okay, so what I've done is I've gone over blue all my quarters. So this is 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, 8 pi by 4. This would be 9 pi by 4. So you can do that counting around the circle. Maybe you also know that, 2 pi is equal to 8 pi by 4. So it's easy for you to see that 9 pi by 4 is 1 pi by 4 past 8 pi by 4, right? However you get there. And so how they show the answer, so if this was a quiz question, is they would just put a big circle here. So you'd pick the answer that has, 9 pi by 4 marked in the first quadrant at the quarter mark. Okay, so now this one is read in a counterclockwise direction. Can you count by sixths and determine where negative 7 pi by 6 would be? Pause the video and give it a go. So for me, I'm going, right, this is 0 pi by 6. Then I've got 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6. So this point here is going to be negative 7 pi by 6. All right, that is the end of the first video. So hopefully you're kind of getting an idea of how to break the circle up into radians. And just a word of radians are awesome is that they feel really weird to start, but when we start doing things like evaluating, the ratio of the sine of pi by 3, then, you're you're going to be like, oh, the reference angle is pi by 3, which is, you know, your 1, 2, root 3 triangle, and you're going to make all those associations. But the first thing you have to do is just get comfortable in radian measure, right? Breaking up a circle up into quarters or sixths or halves, and then looking at where an angle would exist.